Hello friends, welcome to another session on Quant. So what we do today is a topic which is very relevant for your CAT, and we have done the problem sessions level 1 and problem and the foundational session both in the previous couple of sessions. So if you have not gone through them, I urge you to go through that first, because this is going to be the problem session 2. So when I say problem session 2, obviously we are going to talk about a few complex level problems, and the topic is quadratic equation. Not absolutely very complex, that is not relevant for your CAT, nothing like that. What we are going to talk today is all about your what is the topic things that are very relevant for your CAT, and where certain concepts or certain tricks, certain formulas that will be required to solve things faster. So also we have done few very beautiful problems in problem session 1, so please go through that. And like I always say, if you are seeing this video for the first time or on my channel for the first time, the once we show the question, just pause the video, try to solve it for 2 to 3 minutes. If you are unable to solve, come back and see the solution, or if you are able to crack the problem, come back and see if there are better approach to it, and that's how we go about it. So we'll solve around 10 to 11 problems today, and all a different kind of problem will give you a certain understanding on what are the different type of problem you can expect in CAT from basic to advanced level. So some of the basics we have done in the previous class, some very good problem we have done in the previous class as well, not absolutely basic, but we'll do some of those refresher today and move to certain very good problems in today's session as well. But yeah, having said that, in these two sessions together, we will be covering around 20 odd problems on quadratic equation. I think around 22, 23 kind of problem. But the ask is you do 3x as a practice. So you have to do at least 60, 65 problems in quadratic equation to get a complete hang of this. So these are the building blocks of certain chapters. Once you move closer to your CAT exam date, you will not get much time to prepare a particular topic this closely. So this is a very important part of your CAT preparation. So let's get started right away. Okay, so let's move on, see what's the first problem is. So the first problem talks about finding the quadratic equation who have rational coefficient. By rational coefficient is the non-rational number. So what is a rational number? Quickly recovering, what is a rational number? If a number can be represented in P by Q format, where P, Q are integer. So any number that can be represented in P by Q format, where P and Q both are integer, that becomes a rational number. But 6 plus root 5 is a number which cannot be typically represented in P by Q. But if you do this by 1, the top part is not rational. So this is an irrational number. Right? This is an irrational number. So if the if the coefficient has to be rational, then irrational roots occur in conjugate pair. Now, what do we mean by conjugate pair? By conjugate pair, I mean if one root is 6 plus root 5, the other root will be 6 minus root 5. So this is called as conjugate pair. So irrational root always occurs in conjugate pair. So these are the two roots. So how to write the equation if I know the two roots? It's x square minus sum of the roots. So 6 plus root 5 plus 6 minus root 5 into x plus the product of the root. 6 plus root 5, 6 minus root 5. Right? So this becomes x is this equal to 0. So this becomes x square. So root 5 get cancelled, minus 12x. And this one become a plus b into a minus b kind of a thing. So this becomes a square minus root 5 whole square is equal to 0. Finally, we will get x square minus 12x plus 36 minus 5, 31 equal to 0. So this is what we'll get as the equation that they are asking us to find out. So again, quick recap. Whenever the irrational roots are there and your coefficients are rational, irrational roots will always occur in conjugate pair. And by conjugate pair, I mean if something is a plus root b, the other will be a minus root b. So we know both the roots, and when we know both the roots, is x square minus sum of the roots into x plus product of the root. Basics of quadratic equation we have covered in the previous fundamental session. So that's why I'm saying please go through the previous, at least the fundamental session, if not the problem session one. Then it will be very easy for you to relate. We have in detail talk about rational root, irrational root, knowing two roots, how to find the quadratic equation and stuff like that. Okay. So all those videos will be given in the description box. You can have a look. Now find the equation whose roots are thrice. So if you remember, we said if alpha beta are the root of an equation, let's say ax square plus bx plus c equal to 0, and okay, so ax square plus bx plus c equal to 0, then if roots are becoming thrice, so then if the equation, if another equation has roots as 3 alpha and 3 beta, then that equation must become a by 3x square plus b by 3x plus c equal to 0. So this is going to be the root. So in this case, this will be x by 3 whole square minus 18 by 3x minus 36 equal to 0. That means x square by 9 minus 6x minus 36 equal to 0. And then you can multiply with 9 and then you can go ahead. So that's the whole graph. So if roots are thrice, your x will become x by 3. If roots are 1/3, your x will become 3x. Again, a complete deep dive on how we do this kind of problem when one equation and their roots are given and the roots are changed in a certain way. You have to find the new equation. Then that's the approach. Whatever happens to the root, do the reverse to the x in the new equation. So if the roots are multiplied by 3, you make the x by 3 and find the new equation. If roots are added, if 5 is added to the roots, then you make x as x minus 5 and then find out the new equation. That one. So if instead of 3 alpha 3 beta, if it was alpha plus 5 and beta plus 5 are the new two roots of the equation, my equation would have become a into x minus 5 whole square plus b into x minus 5 plus c equal to 0 kind of a thing. So again, we have given an exact detail in the foundational session, so we can go through that. Okay. Now this talks about x square plus kx plus 64 equal to 0 are non-real. So when roots are non-real, means roots are imaginary. If I say roots are imaginary, now we know x is minus b plus minus root over b square minus 4ac. That is the generic solution by 2a. Now, if b square minus 4ac is less than 0, or in other way we can say the discriminant, which is this, the discriminant is less than 0, then you have a negative sign under the root. If you have a negative sign under the root, then number becomes imaginary numbers. So if you know that this is going to be less than 0, that's when roots become imaginary. So if we have to say b square minus 4ac has to be less than 0 for roots to be imaginary or non-real. So b square is in this equation, I have x square plus kx plus 64. So b square is k square minus 4 into 64 into 1. A is 1, c is 64. This has to be less than 0. So k square must be less than, sorry, 4 into 64. Or I can say k must be less than 2 into 8, both plus minus. So can I have minus 16 less than k less than 16? So k, take any value between minus 16 to 16, these roots will become non-real or imaginary, because b square minus 4ac will be less than 0. This plus minus. Okay. So let's move to the next problem. What it says, find the equation whose roots are equal in magnitude but opposites in sign. So if you have ax squared plus bx plus c equal to 0, if you make this b as 0, then your equation become ax squared plus c equal to 0, or x squared minus c by a. Now I can say x is equal to plus minus what, c by a or something, minus c by a. So the only way roots are equal but opposite in sign is when b is equal to 0. So this is a very new learning. Why we keep this in problem session 2? Because these are not very normal scenario. These are some of the specific scenarios that being asked in CAT or in MATLAB FT. So if you know this equation, when the roots are equal in magnitude but opposite in sign, your b has to be equal to 0. So but here what has been asked, if you see typically a whose roots are even but opposite in sign for x square minus 18x plus 36. So this is one thing we will use this in future, but here what they have asked, x square minus 18x plus 36, right? So what we can do here is, so let's say alpha and beta are the root of x square minus 18x plus equal to 0. If the roots are equal in magnitude, opposite in sign, means both alpha beta has to be multiplied with minus 1. So that means minus alpha and minus beta if at the roots. So basically what you are doing, you are multiplying with minus 1. So what I have told before, if you change the roots by certain thing, you have to do the reverse in the existing equation. So if I'm multiplying with minus 1, I have to divide with minus 1. So x by minus 1 whole square minus 18 by minus 1 into x plus 36 equal to 0. Or here we can say x square plus 18x plus 36 equal to 0. You don't have to find out the roots of x square minus 18x plus 36. You just need to understand how the existing roots become opposite in sign but equal in magnitude. So opposite in sign, equal in magnitude, you have to multiply by minus 1. If you multiply by minus 1, you can divide the existing equation by minus 1. All the x's by minus 1. Your x in the existing equation become x by minus 1 in the new equation, and that's how you go ahead and find the new equation. Okay. Rather than solving x square minus 18x plus 36 equal to 0, get the two roots and change the and find the new two roots and then again find the equation. This is much faster approach. Whatever we told you on the top, that will be relevant in the coming ones, but this is normally happens when the roots are equal in magnitude but opposite in sign. Your b has to be normally equal to 0, but that's for one root, one equation, not applicable in this problem. Okay. This would find the maximum value of the expression 9x minus 7x square minus 18. Again, this is a very good, important kind of a problem. So if you remember what we said, ax square plus bx plus c equal to 0, what is geometrical representation of this? If a is greater than 0, your equation should be like this, right? Upward parabola. If a is less than 0, your equation should be like this, inverted parabola. Now here in this case, I can see minus 7x square plus 9x minus 18 is the expression. So that means it's an inverted parabola because a is less than 0. So what you can get a maximum value. So this is the maximum point. You can't get a minimum because minimum is infinite, because it's an inverted parabola. So minimum will be keep going down as and where if you increase the parabola size. Therefore, if you keep extending the parabola, minimum will be getting more and more minimum. Similarly, for a is greater than 0, you won't get a maximum. So here minimum is infinity. You won't get a maximum, so you get a minimum here, and maximum is infinite. So that's the difference. So here they ask for maximum. If they would have asked for minimum, we said it's infinity. If they have asked for maximum, so normally dx plus c equal to 0. I'm not going to show you how to find out the maximum minimum because that's a differential equation kind of a state. So someone who has done differential equation, for them I'll just quickly show. So if I have an expression ax square plus bx plus c, then first degree of differential equation is 2ax plus b. If you have not done differential equation before, just ignore this 10-15 seconds. And since this f double dash is 2a plus b, sorry, 2a double dash is 2a. So this is what we get. So this is a positive equation. So that's how we can figure out what is the value of a maximum or minimum. So from here there are steps in differential equation. If we put back the value of x equal to 2a in x square plus bx plus c, the value you get is the maximum value. So normally it's written as, so in this equation the maximum or minimum when we find out is value of this expression is 4ac minus b square by 4a when x equal to minus b by 2a, right? How you get x equal to minus b by 2a? Because f dash x, so the first degree of equation you have to make it equal to 0, and from here you can say x equal to minus b by 2a is when the equation gets a maximum or a minimum, depends on the sign. So if 2ax plus b is positive, you get a minimum. If it is negative, you get a maximum, kind of a thing. Depends on the sign of b and a. But x equal to minus b by 2a, the value will become, and with the value of 4ac minus b square by 4a, then you can find out this 4ac minus b square by 4a is the maximum. But m double dash is equal to 2a, so you can say if a is positive, then ax square plus bx plus c will have a minimum. If a is negative, ax square plus bx plus c will have a maximum. The same thing is validated in the graph as well. If a is less than 0, you have a maximum. If a is greater than 0, you have a minimum. Same thing is validated here. But if you, so the second step of differential equation tells you what value of x there will be a maximum and minimum. The second differential of x this will tell you whether there will be a maximum or there will be a minimum, and that depends on the sign of a. But at x, if you put x equal to minus b by 2a in this equation, you will get 4ac minus this expression. If you on the right hand side in this expression, if you put x equal to minus b by 2a, you get 4ac minus b square by 4a as the maximum or a minimum value. Now here we will get the same value as minimum, sorry, maximum, and then we just need to replace. What is 4ac? 4 into a, which is minus 7, into c, which is minus 18, minus b square, which is 9 square, by 2 into minus 7, right? So this is how you can solve it. So that means 28 into 18 minus 81 by minus 14. Okay, so that's about it. And if, so this will become, if you do minus 423, sorry, this is 4a, so this will be 4, so this will be minus 28. 423 divided by 28. So if you do this, you'll get this. So this is the maximum value of this expression. So hope this is clear. We will move to the next problem. It says a single digit odd number and b is a natural number. So what are the single digit odd number? So a can be 1, 3, 5, 7, and 9. So these are the possibilities of a. B is a natural number. How many equations of the form have real roots? So real root mean, so if I say real root, then I have to say a discriminant must be greater than equal to 0. And what is a discriminant? Discriminant is b square minus 4ac then equal to greater than equal to 0. So this is coming from the equation of ax square plus bx plus c equal to 0. So if this is the equation, then b square minus 4c has to be greater than equal to 0 to have real roots. So in this equation, x square minus 8 root ax plus 7b equal to 0. What is your b? Your b is minus 8 root a. So minus 8 root a whole square, that is b square, minus 4, a is 1 and c is 7b. Right? This has to be greater than equal to 0, right? So this has to be greater than equal to 0. What is this? This is 64a minus 28b has to be greater than equal to 0. So we can say 28b has to be less than 64a. 28b has to be less than 64a. So that means b has to be less than 64 by 28a, or b has to be less than, if you do with 4, so 16 by 7a, right? B has to be less than this. Now if you think, let's say a is 1. If a is 1, that means b has to be less than equal to 16 by 7. B has to be less than equal to 16 by 7. 16 by 7, if you do it in a fraction, it has to be less than 16 by 7 or equal to what is 2 point some number. So b has to be less than equal to 2. So b can be either 1 or 2, because b has to be a natural number. So these are the two possibilities. When a is 1, b has to be 1 or 2. Similarly, when a is 3, b has to be less than equal to 16 by a is 2 point something. So 2.xx. So okay, you can do it like this also. So b can be less than 16 by 7 into 3, or 48 by 7, which is b has to be less than equal to 7, because 48 by 7 is 6 point something, or as a whole number it is less than 7. B has to be less than 7. B has to be less than 7 means b will have 6 values. So b has 6 values: 1, 2, 3, 4, 5, 6. So when a is 1, b has 2 values. When a is 3, b has 6 values. Now let's see if we can do this further. So when a is 5, b is what? 16 5s are 80, 80 by 7, or we can say this is less than 7 12s are 84, so less than 12. So b will have 11 values. So if b is so a is 5 means b has to be less than 80 by 7. So this is b has to be less than equal to 80 by 7, or b will have to have 11 values. When a is 7, b has to be less than equal to 16 7s are 1 1 2, and 7 7 will get cancelled. So 16 by 7 into 7, or b has to be less than equal to 16. So b will have 16 values. So 16 values. So and finally you have to see when a is 9, right? When a is 9, b will be less than equal to 144 by 7, or b has to be less than 21, or you can say 20 values. So when a is 1, b will have 2 values. When a is 3, b will have 7 values. When a is 5, b will have 11 values. When a is 7, b will have 16 values. And when b is 9, a will have 20 values. So together how much? 2 plus 7 plus 11 plus 16 plus 20. So 9, 20, 36. So 36, 47, 54, 56 values. So the b, for how b is a number, how many equations? So for 56 values of A, there will be 56 values of B, there will be 56 equations. So answer is 56. So for 56 values of B, you will have 56 equations with real roots. I hope this is clear. This is a very good problem. So what we did, we again find out the condition of real root, that discriminant greater than equal to 0, b square minus 4ac has to be greater than equal to 0. And from there we went on, create a relationship between B and A, and then put the values of 1, 3, 5, 7, 9 from the condition of A. And for all of that values, how many values B can take. So for A equal to 1, B can take 1 and 2. If you put those two values in the equation, you will get two different equations. For A equal to 3, B can have 6 values. Okay, sir, my bad. This has to be 6. This has to be 6 values. So this is 6 means this is 6. That is 55. So answer is 55. And then when A is 5, B will have 11 values. When A is 7, B will have 16 values. When A is 9, B will have 20 values. So that's how we can say B will have total 55 values, and all the 55 values of B will give 55 different equations. If you have any doubt, please feel free to drop a note in the comment section. We'll be able to help you. Let's move to the next one. Alpha, beta, gamma. So this is a very important one. So if you remember, before we solving this alpha, beta, if we say roots of the equation, then we can say the roots are basically x square minus alpha plus beta into x plus alpha beta. If the actual equation is ax square plus bx plus c equal to 0. So alpha plus beta, so the sum of roots individually is always minus b by a. Alpha beta is c by a. So this is for two roots or the quadratic equation. If it is a cubic equation where there are 3 roots, so then when there is alpha, beta, gamma, so the same thing will apply. So then when we take all the root at once, alpha, beta, gamma, and let's say the equation is ax cubed plus bx square plus cx plus d equal to 0. Then alpha, beta, gamma are the roots. Alpha, beta, gamma are the roots. Since x has 3 values, so 3 different roots are there. So every root individually gets added will be first minus b by a, which is there. If we take 2 roots at a time, alpha beta plus beta gamma plus gamma alpha, it will be c by a. See, the sign is changing. First it was when it's all taken each root individually, it is minus. Taken 2 roots at a time, it is plus. And then when I take all the roots at a time, alpha, beta, gamma, or the product, it will be again be minus b by a. Similar thing you have seen here, it's first minus, then plus. So I'm trying to make it a trend, right? So like this, for example, if you can write ax to the power 4 plus bx cube plus cx square plus dx plus e equal to 0, and let's say the roots are alpha, beta, gamma, and delta. These are the 4 roots. How you can do it? If we apply the same thing, alpha plus beta plus gamma plus delta is minus b by a. Taken every one at a time. Then if I take 2 at a time, alpha beta plus beta gamma plus gamma delta and so on, it will be c by a. Then if I take 3 at a time, alpha beta gamma plus beta gamma delta plus alpha gamma delta and all that scenario, it will be minus d by a. And if I take all the 4 at a time, alpha beta gamma delta, it will be by a. So if you see, first B negative, C positive, D negative, E positive. Similarly here, B negative, C positive, D positive. So that's how we do. So it's alternatively sign is changing as and when you take from 1 root at a time to 2 root at a time to 3 root at a time. So first we have only 2 roots. So there is only possibility of taking 1 root at a time and then 2 root at a time. So it's alternate. Starts with minus, then plus, then minus, then plus. So it is minus, plus, minus. So here it is minus, plus, minus, plus. So hope this is clear. So this is important extension of your quadratic equation. So now in this equation, so you can take a screen grab of this. Now I'll move this to solve the previous problem. So just give me a minute. Now this is there. So then what they have said is now you know alpha plus beta plus gamma. Alpha plus beta plus gamma in the given equation has to be minus b by a. So minus 9 alpha beta plus beta gamma plus alpha gamma. So this is alpha gamma. This has to be c by a. C is 7. So 7. And alpha beta gamma has to be minus d by a, or it's minus of minus 3 by 1 or 3. So these are the three values. Yeah. Then this is a very important understanding. Go to the next one. When it says when the polynomial is divided by a number, find the remainder. So again, if fx is divided by a, your remainder equal to when you put f of x equal to 3. So sorry, not divided by a, divided by x minus a, your remainder will be f of x minus 3. So basically, if it is divided by x minus 3, that means in simple terms, if you put x equal to 3 in the given expression, the value you get, that should be your remainder. If x minus 3 was a factor to it or a solution to this equation, solution to this expression, then by putting x equal to 3, you would have got the answer as 0. By equating this with 0, the values you get, those are the roots. But if you are not equating this with 0, you put any random number equal to x. That's what the remainder is when x minus that number is getting divided. So here I am dividing x minus the expression with x minus 3. So which is same as if I put x equal to 3 in this equation, whatever the value I get, that is the remainder. The remainder is 0, that or it is completely divisible when x minus 3 is a factor of this equation. So x equal to 3, if I put, it will become 4 into 3 cube plus 3 into 3 square plus 7 into 3 plus 8. So this is 108 plus 9 3 are 27 plus 21 plus 8 29 137 164. Yeah, 164 is that. So basically the understanding is if you divide a number with a particular expression, if you divide an expression with another expression, then make it equal to the number you are dividing with, make it equal to 0. If x minus 3 equal to 0, x has to be equal to 3. So if you put this equation value in this equation, you will get the remainder. So the remainder here is 164. So some very good understanding of different type of quadratic equation problems. Hope you are taking a note of these conditions, how it's for cubic, how it's for a polynomial, the similar problem we did in the previous one, this one, how to find a remainder. The next one clearly, if you remember, we said equal in magnitude but opposite in sign, your b has to be equal to 0. And in this question, 3m minus 6 is your b, and that has to be 0. So m has to be 2. Straightforward, but what we need, if what we have taught in some of the previous sections where we talk about b has to be equal to 0. So if I go back a little, think we solve, yeah. So this problem, if you see, we said roots are equal but opposite in sign when b is equal to 0. Same thing, we got the problem right now and we have solved it. Yeah, right. So let's go to the next problem. It says x squared plus 9x plus 6 equal to 0 has two roots, alpha and beta. So we know my alpha plus beta is minus b by a, and alpha beta is 6, or c by a is 1. So find the equation whose root is 1 plus alpha beta. So x square minus 1 plus alpha by beta, sum of the roots. So that means 1 plus beta by alpha. So I'm just adding these two roots, x plus multiplication 1 plus alpha beta, 1 plus beta by alpha. So these are the roots, and this is equal to 0. So from here I can say, and reduce this a little, x square minus 2 plus, this is alpha beta, alpha plus beta into x, plus this is beta into alpha plus beta, and this is also alpha plus beta by alpha equal to 0. Alpha plus beta we know it's minus 9, so from here we can say x square plus 2 into plus minus 9 by 6 into x plus alpha plus beta whole square divided by alpha beta into 0. Right? So we have to just keep solving this equation. So x square, 6 to the 12, 12 minus 9 is 3. So minus 3 by 6, 6 to the 12, 12 minus 9 is 3. So minus 3 by 6 minus alpha plus beta whole square is 81 divided by 6 equal to 0. And we can say 6x square minus 3x plus 81 equal to 0. So this is the equation that they are looking for. Okay, let's move on. Okay, now they said alpha, beta, gamma, the roots of the equation. Again, you know, given the equation alpha plus beta plus gamma will be minus b by a. So that is 9, minus 9x square is there. So minus b by a is 9 because a is 1. Alpha beta plus beta gamma plus alpha gamma is c by a. So that is 19. And alpha beta gamma has to be minus d by a or 20. So these are the three values. Now this is find the value of 1 by alpha plus 1 by beta plus 1 by gamma. So if you do this, it will become alpha beta gamma plus alpha beta plus alpha gamma. So these are the three things. So you have 19 in the top. So the idea is what we have learned. We may not have learned very complex problems, but we have covered different type of problems in in quadratic equation, where we talk about how the knowledge you have learned in quadratic equation can be expanded to cubic or more than cubic equation. So this is the root taking 1 at a time, 2 at a time, 3 at a time kind of a thing. We also learned how to get the remainder of an equation. We also learned how to find out the equal in magnitude but opposite in sign kind of a rule. So all these are very, very helpful and important for you in quadratic equations. So if you have done the level 1 and level 2 kind of session, we have covered almost 20 to 23 problems. So together, all type of problem we have solved. So if you can do now more on this type, all this type of problem, at least 5 from each type, so that you can cover around 60-65 problems, you should be able to an absolute mastery in this area. So I hope you like this. So if you're liking this video, please like, share, subscribe for the algorithm. Please feel free to drop a note or a comment if you think certain things needs to be improved or can be better in the way we are teaching it. The idea is to keep improving, not only you, from me also as a tutor, it needs to be improved and more value adding to you. So if you feel certain things are missing, certain things can be added, please drop a note. We'll surely consider that. And if you have any doubt, drop of that also, you can add a comment or you can drop me a mail and we can take it from there. My mail ID is in the description box. See you next time. Thank you. Bye.